Hey YouTube, welcome back. Today we will talk about reliability. Reliability. Oh, sorry. Reliability in systems, in data systems, in data systems. Okay, and to to try to understand this one, let's just first talk about what is reliability. So you let's say that you have a client and you have a server. So reliability means the server or the application performs the function that the user expects. For example, the client is request for data. So reliability, that means maybe we are getting the data that we are requesting this data for. We are getting the response that we are requesting. Maybe other people will say that it like reliability means that the server can tolerate the user making mistakes or using the software in unexpected way. Maybe the client put wrong token, or maybe the client ask for too many requests to the server, or maybe other people will say that the system prevents any unauthorized access or any abuse. So if the client is not unauthorized, the server will reject it. Maybe we have like a hacker or something want to access our data, the server will reject it. So from all of these things that we can say, all of these things together means basically we work correctly. The server is reliable, that means the server is working correctly. And if we agree on that, then we can understand the reliability as meaning roughly continue. Basically, the reliability is to continue. Wait a minute, because my English sometimes is not that good. So the reliability is mean that the ability to continue con continuing to work correctly. If I did anything in the pronunciation, just forgive me for that. So basically, reliability means that our system will continue to work correctly, even though if something went wrong. This is the main thing about reliability. So the things that the things can go wrong are called faults. Okay, and the difference between faults and failures, faults, let's say that we have this system, and this system has all of these components. Okay, so faults maybe like we have one of the components have a problem, but the entire system is continue. But so one of the components, one of the components of the system has a problem and maybe like fault or something like that. So this is a fault. The failure, let's say that we have the exact same four components of our application. Let's assume that our application has four components or four services. The failure meant that means all of the four components are not available. So this is the difference between the faults and the failures. So let's go back to the things that can go wrong with the faults. So we will only focus on the faults. So the thing can go wrong with the faults, and system anticipate faults and can cope with them, or and the systems that are anticipate these faults and cope with them are called fault tolerance. And the formal and the formal term is maybe like slightly misleading. It just is that we could make the system fault tolerance for every possible things, but it's not that like that, because there is some fault tolerance we can't avoid. But so we will talk today about the faults that we can tolerate. Basically, we will not talk about every faults. So let's talk about the fault tolerance right now, because actually we'll talk about all the three different types of faults. So before talking about the three different types of faults, we want to say that it is impossible to reduce the probability of fault to zero. It's not like that. You will have faults all the time. This is quite important to put in your mind. Therefore, it's best to design a fault tolerance mechanism that prevents faults from causing failures. In this video, we'll talk about how we do that. So, what we our goal is that when we have faults, we want to prevent them from having failures like that, so the system will continue working even though if we have some faults in a specific services, and how to solve these faults actually in the future. So we have three parts of faults. We have hardware faults, hardware faults, and we have software faults. Sorry, software faults. Oh, faults, and we have human faults. Okay, so I have this type of faults. Let's just first talk about the hardware faults. So in the hardware faults, when we think of code system failure, hardware faults quickly come to our mind. This is the first thing that we think about. Let's say that we have a server and this server have multiple machines working at the same time. Okay. So the hardware forms maybe like one of the machines crashed, maybe the RAM is become faulty, the disk crash, the power grid has a blackout, some of the plugins are maybe in the wrong networks cable, like, and I guess these problems, it sound silly, but they are obvious happening because you are managing tens of thousands of machines at the same time, so you expect that you have this type of problems. Hard disks and or like basically the servers are reported that they having something called a mean time to failure. And the mean time to failure, it's m called m t t f mean file to failure, and it's about 10 to 50 years, and it looks odd. It's 10 to 50 years. I would say, yeah, it's 10 to 50 years. It's not like we have a problem with the machine every 2 days. But if you think about that, we having a machine 10,000 machines. That means we should expect at least one of our machines, one per day of our machine are full, are fail, have a problem. They can't operate anymore. So how we can solve this problem? It's so our approach is that, let's say that we have these servers. So our approach is to usually add redundancy to individual hardware components in order to reduce the failure rate of the system. So disks may be set up in RAID configurations if you want. Maybe servers may have a dual power supplies and hot swappable CPUs and components dies. The redundant component, let's say this is a redundant component, and this redundant component can take its place while the broken component is replaced. So basically, let's say that this has some data, some functions, some API, so it's failed. Maybe it's not working anymore. So the redundant component will take its place. This approach cannot completely prevent the hardware, like this approach cannot completely prevent this hardware problem from causing failures, but it will understood, and it is well understood, and can often keep a machine running with no failures for years. Okay, so for just in a minute. Okay, so until recently, the redundancy of hardware components was sufficient for most applications, since it makes total failure of a single machine failure real. as long as you restore back up onto a new machine. For example, we can just in the redundancy one restore the backup for like the data, things like that, um, onto the new machine. It's like fairly quickly. The downtime in cause of the failure is not it's not something that it's not big. It's not even there. Thus, multi-machine redundancy was only required by small number of applications for which high availability was absolutely essential. For using redundancy was great for the small application. However, as a data volume application, computing demands have increased. More applications have begun using larger numbers. So, for example, AWS is using like millions of machines. It's using, I don't know if it's millions or not, but like AWS using tons of machines. Like for example, the problem AWS can work with this one, and we will talk, I guess, in one of the next videos about something called rolling upgrade and how AWS is solving this problem. But for now, let's know that redundancy in one of the solutions to solve the hardware failure. Okay, so right now we will continue talking about the software errors or software failure. Software errors. Okay, and we usually think of hardware faults as being random and independent, because when a machine is fall down, it's only affect this machine. There is no other machine has been affected by this machine. And from each and one machine's disk, when it fails, it's just simply we just add another machine and for the redundancy component, and that's it. And I will say something in the software, or this is not the case. Like for like I would say that for like such a false harder to anticipate. The software is harder to anticipate than the hardware, because the software affects the full system. And the way to solve this problem is let's just say what software error means. Maybe you have a bug, a software bug that causes every instance. For example, let's say that, where is it? Let's say that we have these servers, okay, 4 servers, and for example that we have um, for example we have a bug, like when we have maybe like a 100 request or something like that. We have a bug that this bug causes the system to fail down when we have more than 100 requests per second, for example. And instead of blocking this IP address, we fail the full system. So, or maybe we have a runaway process that used some shared CPU, memory disk, or things like that, and get to crash the memory. Maybe a service that the system depends on slows down, becomes, for example, let's say that we have again 4 servers, and let's say we have 2 servers, and this server it's want like asks for information from this other servers, and this service is it's too slow, it's inefficient, and this leads to not that good user experience. Maybe maybe when we try to request data, we are getting a false responses. There is a lot of different um, cases about software. So, but you can say bugs. We can just say, okay, bugs, software errors. Let's say it's just bugs. So the bugs that causes these kinds of software faults often be lie on long term, and until they are triggered by an unusual set of circumstances. In those circumstances, it is relevant that the software is making some kind of assumption about its environment. And while the assumption is usually true, it is eventually stopped being true for some reason. So, how to solve this? So, Unfortunately, there is no quick solution to solve this problem and of systematic fault tolerance. Lots of the small things can help. So let's just carefully think about assumption and interaction in the system through testing a process. For example, we will do that. For example, let's say that we don't want to have this problem again. Let's just say we have a four services again, and how can we solve, or like how can we prevent software failures? Of course, you can't prevent it 100%. You still have software failures, but how can you do that? First of all, you can just do some things. First of all, we can use testing. And I will tell you something. In this one, just in this video, we'll just talk about high level. I will not just say, okay, testing. You have to do automated testing. You have to do end-to-end testing, and I will not go too deep in testing. I'll just everything. I'll go on high level right now. So, first of all, we can just have maybe testing, maybe have a process isolation. So maybe a process isolation, it's a good thing. So if one process has failed, that means that it doesn't affect the full application. Allowing the process to crash and restart. Measuring, this is a quite important, that we should allow the process, when the process have a problem, we should allow it to crash and start measuring. And one of the most important also, we could use monitoring. Monitoring, sorry, I should work on my pronunciation. Monitoring. And we have monitoring and analyzing the system behavior. Should analyze also. Analyze the system behavior in the production, of course. If the system is expected to provide some guarantee, for example, in a message queue maybe, or like for in a monitoring, or whatever it will be, it's and it can constantly check itself while it's run, and raise alert if we have any unexpected results. That means that we could solve this software errors. Maybe like we could be quick about fixing these software errors. And we talked about software errors, we talked about hardware errors, and we'll talk about the one of the things that cause errors the most, cause the most errors, which is humans errors. Okay. So what humans errors do actually? Humans design and build software systems. Like us, we are developers, we are design and build the software system. And the operators who keep the system running are also human. Even when they have the best intention and you have the best skills, humans are known to be unreliable. For example, I know back end, and I'm working on back end projects like for a very long time. But of course, I can just cause some bugs. I could create a lot of bugs. It is how it is. It's not something that just because we are human and we are unreliable. For example, one of the studies that said that the human errors, I guess we cause about like 70% of the failures. So it's a lot. So we're talking right now about the 70% of the failures that caused by human errors, but maybe by wrong implementation, by bugs that we are putting, maybe like high pressure on a specific disk. So human errors are pretty a lot actually. We'll take the most piece of the cake. So how we can handle that? So there is, I guess I will say there is a 6 or 7 steps. We can say that the one step that it will be that we'll design the system in a way that minimize the opportunities for error. So we have well-designed system, okay, and just create a good documentation for the APIs, and maybe you have admin interfaces that make it easy to write things and discourage the wrong thing. However, if we want also to make the process quite simple, because if it's not that simple, maybe you find some users are walking around the functionality and you're just doing some things that you didn't expect that they will do. And the second thing is that decouples the places where people make the most mistakes for the places where they can cause failures. For example, um, provide a fully featured non-production sandbox. Provide that use something called test production environment. Okay. And oh, sorry, that is bad. And I will say another thing, that test at all levels. So this is a quite important. Test at all levels. Sorry. From unit tests to end-to-end tests to like automated tests, everything we test all levels to make sure that everything we have as less errors as possible. And maybe we'll say that I would say that the fourth thing is to be allow easy and quick recovery. So allow easy and quick recovery to minimize the impact. And will say that maybe set details, set a lot of details, set up detailed and clear monitoring. It's like I would say that monitoring is it's one of the keys that helps you monitoring. And you just, when you go with production, you just make monitoring and you just test the components, know how many users click this link, how many users click this button, what happens when this button is clicked, and you just could know if there is a problem or not. And I would say that 6, implement a good management practice and training for the complex aspects. Like we should be implemented training for the complex aspect. For example, let's say that your backend developers are using serverless applications. They're using AWS serverless. So we will just provide them with a good training about how to use the serverless service in the best way possible. So you will not get any human failures. So the reliability is quite important. If you looked at how okay, so reliability, I would say that reliability is quite important. If you looked at Fred, if you look at the reliability, you find that bugs in business application cause loss of loss of problems. Many you could go and into legal risks if figures are reported in incorrect way. Maybe we have an outage of if e-commerce sites can have a huge costs. So maybe you could have the reliability. If the system is not reliable, it's a big pain. It's really a big pain. So it's one of the most important things that we should put on our mind, that our system should continue working even though if we have any fault or we have any errors. So this is what the reliability is. So if someone asks you what is reliability, you ask, just give him a quick answer, is that our system will continue to operate even though if we have a small if we have any despite the faults. And it talks about the faults and the failures and what's the difference between them. And that's it for this video. So congratulations for listening for all that. I hope my description was quite good. If you like my content and if you think that my content is worth seeing, feel free to subscribe to my channel and hit the notification bell so you will never miss a video, and see you in future problems.